Today we're talking about graphing linear equations in standard form. Standard form for a linear equation is a times x plus b times y equals c, where a, b, and c are real numbers and a and b cannot both be 0. The x and the y are where we will substitute our x and y coordinates. We're going to use this form to find our x-intercept and our y-intercept. The x-intercept of a graph is the x-coordinate of a point where the graph crosses the x-axis. It occurs when y equals 0. So here would be our x-intercept right down here. So we've got our line, and where it crosses the x-axis is where x-intercept is. It's the intersection of our line and the x-axis. And every point along the x-axis has a y-coordinate of 0. We've got -2, 0, -1, 0, 0, 0, 1, 0, 2, 0, and so on. This first number, our x-coordinate, is a real number that appears on the x-axis, and our x-intercept can be referred to as this first number, the x-coordinate of the point where it crosses the x-axis. The y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis, and it occurs where x is 0. So once again, here's our line. Here is our y-intercept, where our line and the y-axis intersect. And this guy has an x-coordinate of 0 because everything along the y-axis has an x-coordinate of 0. We have 0, 0, we have 0, 1, 0, 2, 0, 3, and so on. So the y-coordinate is our real number, and the y-intercept can be referred to as just this real number, since we know that it's always going to start with 0. Let's look at some horizontal and vertical lines. So now that we know about the x and the y-intercept, here we have a line, and we've just highlighted the y-intercept. We've called it 0, b. The equation for this line is just y equals b. The graph of y equals b is a horizontal line passing through that intercept. So let's see an example of this. So b is a real number. So let's say we're graphing y equals 4. That means that all of our coordinates have to have a y value of 4. So I can have 0, 4. I can have 2, 4. I could have -3, 4. I could have 5, 4. They all have a y coordinate of 4, including the y-intercept, 0, 4. When I connect them, they make a horizontal line. So when I see an equation with just a y equals real number value, I know that I'm talking about a horizontal line that intersects the y-axis at 4. When I'm looking at vertical lines, they have an x-intercept, and the equation for those vertical lines is x equals the number that is our x-coordinate for that x-intercept. The graph of x equals a is a vertical line that passes through the point a, 0. This particular number that is our x-coordinate is also in our equation. So let's look at an example of that. So let's say we're asked to graph x equals -2. That means our x-coordinate has to be -2. I can have -2, 0. I can have -2, 5. I can have -2, -1. I can have -2, -3, as long as my x-coordinate is -2, especially the x-intercept. It's at -2, 0. When I connect them, they make a vertical line. So when I see x equals a real number, I know that's going to make a vertical line. Now, most of our graphs do not end up as horizontal or vertical lines. A great majority of them are diagonal lines. So let's see how we can use our standard form to help us graph a diagonal line. So if we're graphing something that comes in a linear equation in the form a times x plus b times y equals c, we're going to find the x-intercept and the y-intercept and then connect the line through those 2 points. So in order to do that, we're going to start by finding the x-intercept. Remember, all x-intercepts lie on the x-axis and have a y value of 0. So we're going to substitute in 0 for our y. So 3 times x plus 4 times 0, because we're substituting in 0 for y, equals 12. Well, we're basically out of this going to get 3x plus 0 equals 12, which is the same as 3x equals 12. And to make this equation true, x has to be 4. So our x-intercept is at 4 comma 0, so right here. Now we're going to do the exact same thing to find our y-intercept, except for y-intercepts, since they're all on the y-axis, the x-coordinate is always 0. So I'm going to substitute in 0 for my x-coordinate. So 3 times 0 plus 4 times y equals 12, which is basically 0 plus 4y equals 12, or just 4y equals 12. To make this statement true, y has to equal 3. So my y-intercept is at 0, 3. Once I have both of my intercepts graphed, all I need to do is connect the line between them. There's my diagonal line.